Assalamu alaikum. Today I will be going to explain you guys a multi-tenant system or a multi-tenant architecture. My startups, I'll show you my startups. I'll just show you the links so you have an idea. When it's ready, you can always visit it. One is the ERP system. This is multi-tenant. Also, if you look up the agent.offerberriesvio.com, this is also I'm developing this is also a multi-tenant system. Similarly, there are other systems. I will quickly show you examples. Multi-tenant SaaS. So the famous names I would want you to recognize here, if I can find the examples. Multi-tenant SaaS examples. Yeah, Slack, Atlassian, Google Workspace, Salesforce, HubSpot, Shopify, Wix, GitHub, Vercel, Dropbox. These are all multi-tenant architecture, right? There is a lot of content on YouTube because it's a really popular architecture of SaaS applications. If you are developing a SaaS application, there's no way that you will avoid using the multi-tenant architecture. So as I'm using it, many big companies, big names are using it. You can use it as well. So in this video I will be sharing how you can make a multi-tenant architecture just as I have used in my products. So the first thing is you need to understand the business domain, when to use this. You can use this when you are making something that is in the business to business category. You are developing a business for other businesses. Like if I give you the example of the software Slack, Shopify, Salesforce, these are softwares, products built for other businesses. These are businesses established for other businesses. So whenever you are in making something is this domain, go for business to business, go for the multi-tenant architecture. And if you are making something for the customers, which is basically business to customers, such as Instagram, it's for normal users, Facebook, it's for normal users, right? So the softwares that normal customers will use, one user, not many users, as another, and a business has multiple users inside it. We pack multiple users inside a name and we call it a business, right? So this overall thing, this is this is a tenant, right? A group of basically employees, group of users, or you can simply say a business. So this is a tenant. If you are making a system for a single tenant, that is called a single tenant architecture, or a single or the product that will the product architecture will be called single tenant architecture. But if you are making something in which there is one common code base, and similar multiple tenants are using it, right? If I group this together, if this is one tenant, how to group it? I think it's Control G, yeah. So if multiple tenants such as this, they are using the system, it will be called a multi-tenant system. I'll just connect this so you have an idea. One common code base, multiple businesses are using it. So this is a multi-tenant architecture. Now a multi-tenant architecture is made when you do such changes in the code base that will isolate the data of this tenant, and this tenant, right? So if you can do this, if you can really isolate the data of all these tenants using logic, you will be making something called the multi-tenant architecture. So there are ways to implement it, right? There are ways to make the multi-tenant architecture. I will dive into the technicalities now. If you are making a small project, you don't necessarily, if you're making a project that just one single entity will use, that means your system will just be dealing with the data of one single tenant or one single customer, right? But if it's a multi-tenant architecture, that means one system will be dealing with the data of this tenant, similarly this tenant, and this tenant. So all of them has their own separate data. So if this is my backend, this is my backend, and my backend accepts requests from this tenant, this tenant, and this tenant, right? It is my job to return the data that belongs to this tenant correctly. Similarly, I need to do this for him, and I need to do this for this tenant as well. Now, what does this explain? This tells me that you have to implement some kind of logic in your code base. Whenever a request is made, the response that goes back, the response is relative to this tenant, right? I'll explain this with an example. If you have a ERP system, which I have, which I am developing, I'm making an ERP system. If you happen to have an ERP system, you know that each tenant has its own HR, meaning each tenant will have its own set of employees. This HR will have its own employees, this HR will have its own, and similarly so on for a number of HR. Each will have its own employees, each employee will have its own salary, each HR will have its own set of attendance, right? So there will be a separate data for each of this business, right? This business has its own data, this has its own data, this has its own data. So whenever the backend is doing a request to a database, normally what you do in a non multi-tenant architecture or a single architecture, you don't care about the data that is coming back, if it belongs to this user, or this user, this tenant, or this tenant. But if it's a multi-tenant architecture, you need to care about this. So whenever you're making a request to the database, it's really important. This is basically the implementation part. Now we are implementing it, we are making the correct mental model, because developing the correct mental model is really important. So you have to, I'll explain you with two set of examples so you can understand. Let's put it here, and yes, let's put it here. Yeah, this is basically a multi-tenant architecture in which all of the tenants share one single database. This is a multi-tenant architecture in which every tenant has its own isolated database. If your tenant wants to have its own separate database, first of all, this will be great because this is physical separation. But if your tenant happen to have a low budget, you will most of the times giving him a system in which everyone shares the same database. What we usually learn in our database course as well, that whenever we are making an application, we just have this one database to which all of my backend is fetching data from, right? But this is hard. The data isolation here is hard. It is really difficult to isolate the data of this HR, and this HR. Let's say if this HR makes a request, and if I happen to read the let's say my code base, this very code base, it has some tables, which is basically, let's say, the salary, the employees, etc. Now if this HR makes request to my system, the same table, there is just one table in a shared database. This is the problem. This database just has one salary table. This database has just one table of employees, and so on. So we have one table in a shared database. In that table, we have stored the rows of this HR, we have stored the rows of this HR, and we have the rows of this HR. Basically, we have data of all of the employees in one single table, right? We have one single table which has data. This is, let's say, salary. Now we have to do the filtration, right? We have to say that, okay, when a tenant is making a request, and database, when you need to return some data, you need to make sure that you filter on the basis of this tenant, right? So you need, in each of your request, or in whenever I make a request from you, it's really important that you give me a response with a filter applied, which will be basically, if it's a SQL, you would have something like where tenant ID is equal to 123 or so on, whatever. Similarly, if it's MongoDB, you need to have a tenant ID applied here as well, and you would have to apply this function where it says find one, and always apply this filter. So this means that the rows that we are going to get from this shared salary table, those rows will be for this HR, and when this HR makes the request, the rows will be for the rows that will be returned to this HR. It belongs to him. Why? Because now we have applied a filter. If we don't apply this filter, there will be data leak, which is a huge problem in a multi-tenant system, because you have not applied a filter on your request to the database. So sometimes you're fetching this HR needs, when this HR requests my backend for the data, I return him the data of this HR, because I don't know, or he did not specify which data do I have to fetch from the database. Is it for him, is it for him, or is it for him? So this is logical separation. Logical separation is when you have a shared database and everyone is using this shared database, and you have to apply these filters on each of your query to the database. You have to apply this tenant ID filter. Now this is logical separation. The physical separation is when the request is made to a database, because everyone brings on their own database, or I provide him a separate database. This HR says that backend, you need to act as the middleman, and when I want my data, you need to fetch my data from my database. Similarly, the HR2 requests this and HR3 requests the same. So this is now physical isolation. We don't have to worry about applying these filters. We now have a separate isolated database for each one of these guys. Now this has a problem. This has a problem that you have to now maintain each of the database separately. You have to maintain the database of this HR separately, and you have to maintain for this HR similarly. But when you have a shared data, the complexity is less. This means that we only have to do the maintenance of one database, and we don't have to do the maintenance of all these database, which means the operational cost of a multi-tenant architecture that is using one shared database is a lot less as compared to a system that provide isolated databases. So my first point here, the data is protected, the data leakage is not that common. Here data leakage is common, but the operational cost reduces. So you have to be careful while implementing the system, because sometimes you do over engineering. If you're getting started, if your startup is just getting started, you always will start with one shared database. You will never start with databases that you will never start with isolated databases. In my system, in my ERP, I am providing the following functionalities. I am providing the users the functionality of a shared database. I am also providing them the functionality of a isolated database that I maintain. This is really important. I do the maintenance. Here I also do the maintenance. The third option that I'm providing them, bring your own database. This is a really important concept whenever you're building a startup and it has something that involves a user to bring their own database. This means that they will do the maintenance. What you have to do, you have to provide your software. This is your software that you are providing. You are providing them your backend and your front end. They are bringing their own database, so you don't have to pay for that database. You don't have to maintain that database. The software acts as the middleman. That's it. There is a famous quote which says that the middleman always earns the most, which means that if you can act as a good middleman, you will benefit a lot, right? You are not maintaining things, the overhead is less, and you are earning more. So if you think about it, if you have a software that can serve a lot of databases that people bring, this means that you are just charging them for your code. The database maintenance, if I talk about MongoDB has a 180 or more yearly tier for their database, for the MongoDB Atlas, which is expensive. Similarly, if you're not using MongoDB, you would have to host the database on a local machine, on a local server, and you would have to do the manual maintenance, which is not easy as well. You need RAM for it. If you are setting up a non-SQL database such as MongoDB, you would have to set up a something called as a replica set with that database as well, because your system will probably contain something called transactions, which is a concept of system design. So basically what I'm trying to say is that your raw machine will have to do the maintenance, your space will be occupied, so it's really difficult. But if you bring on your own database, you just have to provide them a front end, and you have to tell them kindly enter your DB credentials, and you will just connect them with the database, right? So this is really useful. And the fourth option that I'm providing them is basically set up on site, local setup. By local setup, I mean, if you think about an ERP, every organization would want an ERP set up in their own servers that are on site, not on cloud. So if it's on site, I'm also just providing them this middleman. I'm just providing them the software. They will connect their own databases, and I will just have to make my system tenant configurable. The first thing that I focused on was tenant isolation. How would you isolate the data of each tenant? Now the important part is tenant configurable, because when you are making an ERP, right, let's say if you are making a tax, you have a finance in your ERP, and this finance includes taxation. Now if this ERP is used by someone from Pakistan, they will have their own set of rules. The UK user will have their own set of rules for the taxes. The US user will have their own set of the taxes. So whenever someone comes to your software, you have to make sure that your software is tenant configurable. Tenant configurable means that you allow a tenant to customize according to their own use. So if you want to make something tenant configurable, you will never hard code anything. This is strongly not allowed, because if you are hard coding logic, if you are hard coding the rules, let's say if I hard code the rules or I hard code the logic for the PKR. Now if a US user is using the ERP, he will get the rules, or he will get his response always with the Pakistani taxes applied. So you can never hard code things. You will always allow a user to set up the things. So when you are making such a system, you will have to make sure that you make the application generic or simply tenant configurable. Means your each single module, each of the module will be customizable. Yes, if there is a standard, let's say if there is a standard followed in the world, let's say there is a standard of chart of account, by choice, this is your decision that you will use a set of numbers, a specific set of numbers for the account names, because chart of account has basically some accounts in them. So this is a choice. You are making it deliberately, you are making a design decision because it's a global standard. So in this case, you don't have to provide the tenant configurability because it's a global standard. But in such modules where it's important that you need to think that who is going to use this module. Is it just my user from Pakistan? Is it just my user? Let's say if my ERP is being used by a hospital, well, hospital have to utilize finance according to their own will or according to their own objectives, but the institutes or the universities, they need the ERP for their own personal goals. So the finance need to be as such that it supports the hospitals as well as the school systems or universities or institutes. So you need to make everything tenant configurable, you need to make everything tenant, you need to make sure that you have the tenant isolation implemented. Once you are done with these two things, the third thing that I will be talking about is the JWT tokens and middleware. So far what I explained you was just the correct mental model. I wanted to make sure that you have the correct mental model, but now I will talk about some backend. I will tell you when someone is making a request to your backend, what are the things that you need to keep in mind, right? And how will you make sure that whenever someone makes a request to the database, or someone fires an event, or someone has something related to that is handled by a worker, or there is a job that is handled by a particular worker, that job is for a specific tenant. How will we ensure that, and how will we verify that whenever a tenant is making a request to our system, that tenant actually belongs to the table, or it is registered in our system, that tenant is present in the tenant table? How will we make sure that he is in our system registered? So if this is my backend, let's make a backend. If this is my backend, and if multiple tenants are making requests to my backend, see these are multiple tenants. If this person or this business is making request to my system, now I will have to enforce middlewares. Middlewares are basically the guards that checks if a specific condition is being fulfilled or not. So I add these guards. What their job is to basically check before reaching the services or the business logic that a tenant belongs to my system, right? So in this middleware, I'll call it tenant, let's say check. I need to check something. I need to make sure that I resolve the request, extract the tenant ID and store it in a JWT token. By this I mean that it's my condition, or I've asked this tenant to always, whenever he is making a request from his backend, he needs to make sure that he sends me a tenant ID. And why is that important? Because I need that tenant ID everywhere in the system, because on the basis of that tenant ID, which I store in a cookie, a JWT token or a cookie, on the basis of this token or cookie, I will always check that whether he belongs to our system or not. This needs to be done in every request, right? So usually when you open a tab, let's say I've opened a tab, as I've opened this tab, let's say this tab is an Instagram, this tab belongs to Instagram, right? So you will have something in your, if this works, you will have something here in the application known as the cookies. A cookie will be created in this section. What this does is it stores your information for a temporary period of time, or usually we call it a session. It stores your information for a particular session. Whenever you close this tab, this cookie is destroyed, means the session ends. So what I am asking you to do is, whenever or if a session is active, you need to once resolve the tenant ID and store it somewhere, so that you don't have to do this on every request. Once you have done it, that the cookie will be available here. Now you don't have to worry about making requests. Your tenant will smoothly make requests, and there won't be this check applied, because this middleware has already extracted it and stored it in the cookie, right? Now this auth middleware basically checks that this cookie is a valid cookie or not. This happens, this will take place on every request, but this will take place only once, because authorization, authorization is really important when you are doing a backend to backend conversation. Everything that you send to this backend, it's checked whether it belongs to, or the request is actually allowed to reach this backend or not. So this is really important. But if you have done this process, this becomes really faster. The service logic is executed safely once this step is done correctly. So you will have to apply these middlewares before something reaches your tenant, right? The next point that I will raise is that in modern applications, the complexity of the backend increases. By this I mean that there is something known as events. I'll try to not dive deep into the events, but there is something which is basically a signal that is fired when a state changes somewhere in your code. Now, a tenant has its own set of events, another tenant has its own set of events, and the other tenants have, similarly, others have their own set of events. This tenant events need to have the context, need to know that, okay, whoever is firing this event, who does this events belong to. So the events always will have the context, mean they will work on the basis of tenant ID that you resolve here with the middlewares. Similarly, if there is a job that is performed by a worker, a job is basically a task that we do asynchronously, that we do asynchronously. Like this task won't wait for another task to execute. You can execute different tasks on parallel, but if it's synchronous, it means that first one task has to be executed, then another task has to be executed. Each waits for each other. You cannot execute things in a parallel manner, right? So the jobs need to have the context of the tenant as well. I'll summarize this shortly. Whenever you are making a multi-tenant architecture, you need to make sure that what you are building will have a conversation with either one single database or multiple databases, or if you want to introduce isolated databases, do you have the infrastructure implemented that can handle and maintain this isolated databases or not? Similarly, if you don't have that facility or infrastructure to support the isolated databases that will allow you physical isolation, you will move toward the bring your own database facility. Means that you just act as the middleman. They can connect to their databases. You will help them in the creation of the database. Now, if your system is implemented on a MERN stack, this means that your system has probably something as a or a function called as the create connection, right? Now this create connection, this is usually for one single database. If you need to support multiple databases, you would need to change this something to something like create connection. Now this is basically facilitating us to connect to multiple databases. Mongoose is the middleman which connects a backend, or it is basically the JavaScript code that allows you to communicate with a MongoDB, a database, a NoSQL database, and your code. So it has this function known as the create connection function. You would have to change that because it usually by default supports the one single database. So you would have to convert to this function. Now by default if you're using a MERN stack, you will have both of them. You will have the support of both of them. Like in my code, I support the connection to one database as well, and I support the connection to multiple databases as well. So by default, if someone is using my system, you will have this mongoose.create connection applied. You would have to change that, and you would have to go for something like this. So you are basically introducing the connection to both of the methods or both of these facilities, shared database as well as the isolated databases. And in your tables, in your schema, if it's a NoSQL schema, you will I think it's something like this. Yeah, it's something like create model and separated by comma, separated by something else. Basically what it does is that it connects to one single database. You would have to change this as well in your schema. You would have to modify your schema. You would have to introduce tenant ID as a separate column in each of your row or in each of your document. If you're using a MongoDB, you will always have this tenant ID, because as I told you, the every query will have the context of your tenant. There's no way that your query will lack the context of your tenant. So yeah, you always need to have this. And this, I guess, pretty much summarizes your multi-tenant architecture and how to what is physical isolation, what is logical isolation, what is the resolving of your tenant ID when two backends are communicating together, why to apply these middlewares, and what options that you can provide to a user in your application. Based on your infrastructure, you need to think that which one to apply. Similarly, you have to have it's really important, your events, your jobs, all of those things have the context of a tenant. And yeah, this is the architecture. Now